Might Proxima B at any point be another Earth-like planet? These are hypotheses everybody continues to make. The quest for an habitable planet and extraterrestrial life on different planets is something that people are entranced with. There have been different hypotheses, and the way that there have been signals coming from Proxima B causes individuals to accept there is something else to it. In spite of this, a large number of signs, we presently can't seem to decide whether these are messages from the planet or just reverberations of our own researcher flags. Frequently, these signs end up being reverberations in seeing if these signs are genuinely from Proxima B. Researchers desire to determine whether extraterrestrial life exists. As of late, the James Webb Telescope identified artificial lights on Proxima B. If you're keen on finding out about different planets and our advancement in finding alternative life, subscribe to our station. We make content about space and discuss developments in science. If you like this content, comment below and share this video with your friends. Now, let's return to our video. Proxima Centauri, around 4.2 light-years from our solar system, is a weak small star classified as GB. Thus, the star is known as Proxima Centauri. It is the nearest star to our Sun and solar system and was named Alpha Centauri in cosmology by Johann Bayer in 1600. The name came from the stars rising around noon while a few celestial bodies, like the Moon and the Sun, were in an orderly fashion. Proxima Centauri is also called Alpha Centauri A, or Alpha. It is a solitary star system with 4 main stars aligned, with Proxima Centauri at the center of the system. Aside from the 4 stars, there are 2 weak dwarfs, Alpha Centauri B, also called Beta Centauri, and Alpha Centauri C. These make up the majority of the mass, but are too weak to be seen by the unaided eye. The system is located 23 light-years from the line of the popular Coalsack asterism in the constellation of Centaurus. Despite Proxima B being a rocky planet, there is still hope that it could harbor extraterrestrial life. The quest for some other life out there has brought researchers to Proxima B. They believe that its similarities to Earth's size and the distance it is from its small star create a viable option for planets that can support life. While all these are theories, there is hope that there may be some truth to them. There is much to discover about Proxima B and the orbit it takes, so stay tuned to find out more. You can also check out some of our other content related to extraterrestrials. Do you really believe there's life out there? Leave a comment down below. What intrigues most about Proxima B is its similarity to Earth. Studies show that Proxima B is an exoplanet that orbits an M-type star. Its mass is considered 1.27 times that of Earth. Furthermore, Proxima B takes 11.5 days to complete an orbit of its star. It was found in 2016, and many researchers are investigating it. Despite Proxima B appearing to be similar to Earth, specific elements make it inhospitable. For one, the planet is too close to its star. As such, it receives extreme ultraviolet radiation from the star, which is estimated to be many times more than the radiation we get from the Sun. The radiation is so strong that it strips away even the light hydrogen particles and, over time, does the same to oxygen and nitrogen. While many could argue that Proxima B should be habitable because it is at a similar distance from its star as Earth is from the Sun, there is more to it than that. Distance doesn't account for whether there is water on the planet, and there is also no evidence of an atmosphere conducive to living organisms. The atmosphere on Earth makes it livable, while Mars does not. The right atmosphere allows for climate regulation and a water-accommodating surface. It also protects living organisms from harmful space weather. If you're with us so far and have not subscribed yet, take a moment to hit the subscribe button. It makes it easy for us to keep creating content like this that you'll love. Now, let's see why people feel that the James Webb Telescope will help us determine whether or not there is life on Proxima B. The James Webb Telescope was launched in 2018 after being delayed since 2011. Many changes had to be made to ensure it provided accurate images during its construction. Webb explained that if a planet like Proxima B could absorb light from a star, it could also emit it as infrared light. The James Webb Telescope was specifically designed to observe infrared light. It can take photographs of this light on the surface of a planet and search for patterns that could confirm whether the planet has water or an atmosphere. One reason why space telescopes are preferred over ground-based ones is that, by being above the atmosphere, they don't have to look through the moving air to see deep into space. Thus, they get a better view of what happens outside the solar system than most ground telescopes can achieve. The other benefit they offer is that weather changes on Earth don't affect them, and astronomers can be confident they're getting a clear reading. The main drawback to having a space telescope is that fixing it is costly. If something goes wrong, there have been situations where a small imperfection in a space telescope requires an entire mission into space to fix it. Such costs make observing planets like Proxima B difficult. With the James Webb Telescope, we have no option for repairs. It has been launched over 1.5 million kilometers away, farther than any human has ever traveled, so salvage missions are impossible. The James Webb Telescope has a larger mirror, allowing us to see way back to the beginning of the universe, nearly 13.7 billion years ago. The further away an object is, the further back in time we get to see it. The reason for this is that a significant amount of time must pass for the light to travel from an object back to us. The ability of the James Webb Space Telescope to see the universe in a longer wavelength in infrared light means we can observe more distant systems in our universe with more certainty than was previously possible. Thus, observing planets like Proxima B has become more straightforward, as it has pushed light out of the visible spectrum and into the infrared. The tab and curve have a size of artificial illumination, a negligible part of how the sun illuminates and reflects the day side of the planet. At 0% on the scale, one would assume that the planet's night side is completely dark. At 100%, it means that the planet's night side is as bright as the day side. There has been speculative progress on Proxima B using this kind of light, and most researchers believe it resembles the early days on Earth. With studies showing that if the night side of Proxima B reaches an illumination of 5% of the regular day side, then the James Webb Telescope could detect the artificial light by 85%. If the brightness reached 9%, the telescope would detect up to 95%. Although 5% illumination seems like a modest number, we're discussing the light from a star like Proxima Centauri compared to our Sun, which provides illumination that is much dimmer. Yet we still have a lot of light from our star. This fundamentally means that at 0.1% of light, we are still reflected in the celestial illumination. In other words, if Proxima B has any civilization glowing like Earth, the James Webb Telescope wouldn't detect it. The stars would need to be many times brighter. This scenario is unlikely since Proxima B orbits so close to its host star that it could very well be tidally locked, meaning one side of the planet always faces the star while the other is in eternal night. A civilization residing on a tidally locked planet could still be visible through airglow, which occurs when atoms and molecules in the upper atmosphere produce light to release excess energy. On Earth, airglow can happen when particles are ionized by sunlight and capture free electrons. The glow resembles an aurora, except that auroras are driven by high-energy particles from the solar wind, while airglow is driven daily by solar radiation. Since the James Webb Telescope's launch, researchers have been wondering if it is sufficient to detect different planets in distant systems. Despite being the farthest space telescope launched, it still provides very little data needed to find planets with life in other worlds. As such, there have been discussions about developing even better telescopes. These endeavors are often expensive and involve a lot of experimentation. The James Webb Space Telescope's launch was 7 years late due to these issues. Thus, it is challenging for most researchers to develop better technologies that can be launched further into space. Despite this, the James Webb Space Telescope results are promising. Soon we could know whether there is life on Proxima B and other planets. While work is still being done on additional telescopes, it is hoped that the completion and launch of the Habitable Exoplanet Observatory, HabEx, will revolutionize space studies. The estimated completion time for HabEx is 2035, with a launch soon after. HabEx will be sensitive to all planets in the universe. Although its primary goal is to search for Earth-like planets, its cutting-edge technology will enable it to measure the spectra of most planets and determine whether they are habitable. HabEx is also believed to have a wide range of astronomical capabilities. This feature will allow HabEx to study the earliest potential times known in human history, gather data, and understand the life cycles and deaths of massive stars, as well as the components that support life as we know it. Despite HABEX still being in development, the technology used to create it will allow it to study Earth-like planets with such exceptional resolution that the images from these planets will be incredibly clear. HABEX will be sensitive to ultraviolet, visible, infrared, and optical photons. The concept behind HABEX is compelling and is set to transform our understanding of space. As scientists continue their search for extraterrestrial life, the advancements in technology and telescopes like the James Webb and HABEX will play crucial roles in revealing the mysteries of distant worlds. With each new discovery, we inch closer to answering the age-old question, are we alone in the universe? Researchers hope that as these observatories come online, they will provide invaluable data about Proxima B and other exoplanets, allowing us to analyze their atmospheres, surface conditions, and potential habitability. The future of space exploration looks promising, and the possibility of finding life beyond Earth is more tangible than ever. Stay tuned as we continue to explore the cosmos and uncover the secrets it holds. Your interest and engagement are vital in driving the scientific community forward. Together, we can marvel at the wonders of the universe and the potential life that may exist within it. If you have questions or thoughts about Proxima B or other exoplanets, feel free to share them in the comments below. Thank you for joining us on this journey through space exploration.